55 jump game from LeetCode. Let's jump to the question. You are given an integer array node. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. So the question is saying an integer array is given, as you see here, and we start from the first index, which is at index 0. And what we are going to do, we are going to see if we can reach the end of the array. And the way we do that, each element in each index indicates the number of steps that we can take forward. So if we have 2 here, it means we can either take 1 step or maximum 2 steps. So as it says here, each element in the array represents your maximum jump length at that position. So for example, if we have 3 here, I can take either 1 step or 2 steps or 3 steps. And let's see how we can reach the end of the array. So for example, if I can take 1 step here and 3 steps here, I can reach the end of the array. Or I can take 2 steps here, 1 step here, and 1 step here, so I'm at the end of the array. Or I can take 1 step here, 2 steps here, and 1 step here, and I can reach the end of the array. It doesn't matter what is the combination, as long as we can reach the end of the array, we can return true. And how about this case? In this case, I can take 1 step here and 2 steps here, and I'm at this position, which is 0 steps that I can take forward. So I cannot reach the end of the array. How about I take 2 steps here and 1 step here? Still, I cannot reach the end of the array, as we have at this position, we have 0 steps that we can take forward. How about if I take 3 steps? Still 0. So as there is no combination that I can take to reach the end of the array, I'm going to return false. So let's jump to the solution and see how we can solve this problem. To solve this problem, we are going to use 2 pointers. One pointer is the next step pointer, and another pointer is the current pointer. And the current pointer starts from length of the array -2, because we don't need to check these because it's at the end of the array, so we don't need to check that. So what we are going to do, we are going to see at each point if the value that we have at each point is big enough to reach the next step. And the way we do that is we are going to have the next step at the end of the array, and we are going to put the pointer here, and now we are going to check if the sum of the index that we have we are located at and the value that we have at that position is bigger or equal to the next step. And you might say, why we are adding the index number to the value that we have? The reason is the maximum number of steps that we need to take to reach the end of the array is, as you see, 1 step, 2 step, 3 step, 4 steps. So it's equal to the length of the array -1. So if I don't use this for checking the length, we might not get the correct result. And I will show you an example shortly. So let's say we are at step 3, which means at position 3, which means we have reached to this position somehow. We don't know how, but we have reached to this position. And now the value that we have here is 1, which indicates the number of steps that I can take from this position. So if the sum of that index and the value that we have is equal or bigger than the index that we are located at, so it shows we can iterate over the next element and we are good at this position. What we are going to do, we are going to update the next pointer and we are going to put update the current pointer as well, right? So now what we are going to do, we are going to check at this position and the value that we have if we can reach this index. So 2 plus 1 is going to be 3, so it's bigger or equal to the next step. So we can update the next step to the current position. So That's what we are going to do. And now we are going to see if at this position the value that we have and the index, the total is bigger or equal than to this. So as you see, 1 plus 3 is going to be 4, and 4 is bigger or equal to 2. And now we go to the next one. Here, this is going to be here, and current is going to be here. And now we are going to see if the value that we have here, which is going to plus 0, is going to be 2, and 2 is bigger than 1. And now we can update the next step to here. So, and we are done with the iteration over the elements of the array. And if the next step, which is 0 right now, is equal to 0, we are going to return true. Otherwise, we are going to return false. Let's see another example very quickly to see if we can better understand this solution. So we are at position 4 and the current is at this position. So what we're going to do, we are going to see if the 3 plus 0 is bigger than or equal to 4, and it is not. So we know that when it is not, this is going to, we cannot update the next step, right? We keep iterating, right? We keep iterating over the array, but we cannot go through this if condition, because this if condition, if it is not valid, I cannot update the next step pointer, right? So it keeps staying the same place, right? But I'm iterating over the array. Current is here, still the sum of the 1 and 2 is not bigger than or equal to 4, and I am at this position here now, and the sum of the 3 and 0 is still 3, which is smaller than 4. And the next, we are done with the iteration over the array, and next step value is 4, and 4 is not equal to 0, and it's going to return false. So the time complexity for this solution is linear, because we just iterate over the array once, and the space complexity is constant because we are not using any extra space. Thank you.